Okay, today we are going to be looking at 13.2. This was a worksheet that you were given in class last period. If for some reason you were absent, make sure you pick that up. But in this 13.2 lesson, we're going to be talking about absolute value equations, and a couple things you should hopefully remember about absolute value. And number one is that absolute value, ABS, is what I'm going to write for absolute value, is always the distance away from zero. Okay, so it ignores positives and negatives, and it just says how far is a number from zero. For example, the absolute value of 5 is 5, and the reason is on a number line, if I have 5 here and 0 here, it takes 1, 2, 3, 4, 5 steps to get to 5. The absolute value of negative 5 is still 5, because on the left side of 0, negative 5 is still 1, 2, 3, 4, 5 steps away from 0. Okay, so absolute value can always be a positive answer, never a negative. And it strictly is the distance away from 0, ignoring direction. Negative just means to the left. Okay, so it's never a negative answer. So there's some quick reminders from absolute value that you should hopefully know. I want you guys with your table to now change pages. We're going to go over to page 1017, 1017. We're going to look at number 4. Right here, and we want to determine these solutions. On number 4, the first one says x equals 5. So obviously if x equals 5, there is only one solution, and that solution is that x has to be equal to 5. Nothing really going on there. That's basically just an algebra 1 thing. However, on part B, we have this absolute value problem. And now the absolute value will equal 5. And just like we did before, we now have two solutions. We talked about this just a second ago. Those solutions are x could be a positive 5 answer because the absolute value of 5 equals 5. However, x could also be a negative answer now because the absolute value of a negative answer or negative number is still positive 5. So basically what we're doing is we're taking these x's and we're plugging them in to the absolute value and getting the result. So now I have two solutions on that one. Part C, we again have an absolute value. This time, however, it equals a negative number. And we should already know that this is not possible, and the reason again is because never can you plug in an absolute value number and get a negative result. It's not possible. You can plug in a negative, you cannot get out a negative. And this is saying after you've plugged in any number and taken the absolute value, you get a negative. So anytime you see a problem like this, with absolute value equaling a negative answer, it is a no solution. It is not possible for that solution to exist. And the last one we're going to look at is absolute value of x equaling 0. Well, this simply means that we again have one overall solution. And the reason is because the only number that we can plug in to get 0 is 0. So if we plug in any whole number, 5, 6, 8, 12, or any negative whole number, negative 2, negative 8, negative 10, we're always going to get the positive answer, but the only way to get 0 is if x is 0. So hopefully we understand all those things, and we can kind of summarize it down here at the bottom, and we can say that if the absolute value of x, or any equation, equals a positive number, we will always have two solutions. Put positive in parentheses. Okay. If the absolute value of x equals a negative number, any negative number, we have no solution. It means there's no value possible that can solve that equation. And finally, if the absolute value of anything here equals 0, we have one solution. Now what you're going to try to do now is you're going to try to solve these equations for absolute values. Okay, it's very simple algebra 1 stuff, but there's a couple things you need to know. So a couple notes that you might want to take down right here. Okay, to solve an absolute value equation, the first thing you always must do is isolate the absolute value. Now, in all of these examples up here, the absolute value is already isolated. To isolate simply means to kind of get by itself. So sometimes that's already going to be done. If it's already done, or when it's already done, the second step is to write an equation. All right, now these are already equations, obviously, but we want to somehow remove this absolute value. So to remove the absolute value, you must rewrite two equations. And we're going to get some practice on this. The first equation I'll do, I guess, in blue here. The first equation is simply to copy equation without absolute values. Okay, so we're going to get a positive answer that way. So for example, here is my absolute value of x equaling a positive number 5. So if I drop the absolute values, I just copy what I see. X by itself equals 5. And that's my first solution. So copy equation without the absolute value. Okay, this should be a positive answer. So again, x equals 5. 5's positive because that's a positive value. Okay, my other equation is we are going to copy the equation without absolute value and write a negative answer. So we're going to copy the equation just like we see it again, without the absolute value in it, but this time we're going to write a negative answer. And let me show you what that looks like. Up here back again, we had a absolute value of x equals 5. If we come down here on my second equation and write it just like I see it without the absolute value, equals, same answer, but it's negative. So one positive answer, one negative answer. That's the way you get rid of your absolute values in an equation. Last thing you should always do is after you've done these two equations, you want to solve the equation for your variable. And some of these you won't have to solve them because they'll already just be an x like we did just a second ago. But in other ones you might have to solve them. Okay, so we're going to get some practice doing this. So with your table there, go ahead and flip over to the next page, which is 1018. And I want to show you a quick practice of this. It's very, very simple. Here is our equation that we're going to look at right now. And I'm going to cross this out because I don't really like how the book does this. They kind of write it a little bit more complicated than they need to, but they still get the same correct answers. Okay? So we have, I'm going to write it on this side here. We have an equation, absolute value of a is going to equal x. So the first thing we should do is evaluate our answer. Since that's a positive answer, it should tell us we have two solutions. So I'm going to drop my absolute, well, the first thing I should always do is isolate the absolute value. So if I look at this, I'm just focusing on the absolute value. So ignore everything else up to the equal sign. And since there's nothing in front and nothing behind the absolute value up to the equal sign, this is already isolated. So my first step is done for me. Then, in order to drop the absolute value, I must write two equations. My first equation is ignore or drop the absolute value. And obviously that is now one solution. The absolute value of 6 is 6, so this works. My second equation is to drop the absolute value and write an equation with a negative answer. And this then I would solve, in which case I'm already done because this one's already solved, but I can check my answer if I plugged in a negative 6. The absolute value of negative 6 right here is still 6, so this one also works. And now I get two correct answers. Notice right here they still have the same answers, but I think it's a lot easier to make the solutions negative instead of the absolute values negative. So what I want you to try to do is stop this video for just a second and see if you can now solve this equation down here at the bottom, number 7. They're giving you the equation absolute value of x minus 1 equals 6. So pause the video real quick, see if you can solve it, and then come back and check. Alright, hopefully you have a solution now. I'm going to go ahead and rewrite this problem just so we can see it a little easier. X minus 1 in absolute values equals 6. Alright, the first step to always solving these is isolate your absolute values. And if you look at this, this absolute value is pretty much isolated. It has nothing behind it. It has nothing in front of it. Don't worry if there's some extra stuff going on to the x. To isolate it, think of drawing a box around that absolute value and making sure it's the only thing on that side of the equal sign. So this is already done for us. Okay? Second thing is to rewrite the absolute value equations. So the first equation is drop the absolute value and make it equal to 6. And then you must solve this. So we're going to add 1 to both sides, and that gives us that x equals 7. So there is our first solution. The second equation is to drop the absolute value and write the opposite answer, or the negative solution. We again solve by adding 1 to both sides. This x will now equal -6 plus 1 is -5. And notice there are our two solutions, and we can check them both. 7, if I plug in 7, 7 minus 1. Well, that answers 6, and the absolute value of 6 is 6, so that one works. What about -5? -5, subtract 1, is -6, and the absolute value of -6 is still 6. So both of these equations work. So we've done all three things here. We have isolated, that was already done for us. We rewrote the equations, and then I should write down here, number 3, we should solve by adding 1 to both sides to get our two solutions. So with your table, I want you to try, pause the video here. On number 8, you are to try A, B, C, and D. So pause this video and go ahead and see if you can get those solutions. You may check your solutions on the answer key with the sub, and if you get those right, then move on to the next part. So the next part, after you've gotten those right, is to now solve 10 A, B, C, and D. And these ones are a little bit trickier because the first step is not done for you, and the first step is to isolate. So now think to isolate by moving anything else. For example, if I see this one, here's my absolute value of 6, here's my equal sign, but next to it I have plus 16. So I somehow have to isolate this by moving the plus 16. So first isolate it. I'll help you out real quick on this one. To isolate, we're going to subtract 16 on both sides. This cancels. I bring down exactly what I see, bring down my equal sign, and bring down 16. From here, to ignore or to get rid of the absolute value, I rewrite two equations because it's now isolated. I write that the absolute value of x drops to just plain old x, and it equals 16. And then I rewrite the other equation as x, drop the absolute value, equals -16. And then I would solve those. In this case, they are already solved. Sometimes you will still have to solve. But those are our two answers, and we're done. So with your table, you need to do B, C, and D. Check your answers when you are finished. Pause the video before I go on. Once you're done with that, we are going to go on then to inequalities. Alright, and an inequality is one we typically think of. I'll write some notes up here. An inequality means it's not equal to. So we have 4 inequalities. Okay, inequality is not equal to, although it could sometimes be and equal to. Alright, and those ones you probably remember from middle school and elementary school. Those ones are less than, greater than, less than equal, greater than equal. And those are the 4 things that we are going to do today. And it's very important that you remember something. I'm going to come down here to the bottom, so we're not going to worry about the word problem just yet. But if I have a number line and I say that x has to be greater than 5, well, I'm going to go find 5 and hopefully remember how to graph these things back in the old days. But if you were to pick some x numbers that are greater than 5, those numbers would be to the right of 5. 6 is bigger than 5, 7 is bigger than 5, 8 is bigger than 5, etc. So to graph this, we would graph what's called an open circle because we can't equal 5. 5 is not bigger than itself. And then we would shade on one side of the number line with an arrow saying forever it's going to be bigger. Okay? So one thing that we can do is, when we graph these, is think where on the number line these numbers are. However, we can always do anything to equation as long as we balance it. So let's say I multiply this side by 2. 2x's would have to be greater than 10. And if I solve this equation, that still means that x is 5, because 2 times 5 is 10, and that means we want all the numbers that are bigger than 10. So this equation really reverts back to that if I reduce it back down. I could also multiply it by any number, or I could add a number. X plus 1 is greater than 5 plus 1, which turns into an equation of x plus 1 greater than 6. Notice my x number up here in my number line is still 5, because 5 plus 1 is 6. So I want all the numbers bigger than 6. So this still, again, reverts back to the exact same equation, reduced down. Okay? And the reason I'm doing this is because you need to know what happens when you multiply by a negative. What happens if I multiply x, not by 2 or not adding, but multiply it by a negative? What happens is then 5 becomes negative. So I'm multiplying the left side and the right side of my original by negatives. And I can do that because I'm balancing it. Negative on the left, negative on the right. However, now if I pick a number over here, 6 or 7 or 8, that should make this true, it will not be true anymore. So let's say I pick 6 and I test it. Is negative, that's already there, 6 greater than negative 5? Well, let's go over here to the number line if you're not sure. Here's negative 5 on our number line, negative 1, negative 2, negative 3, negative 4, negative 5. And here's negative 6 on our number line. Is negative 6 greater than negative 5? Well, hopefully you said no, because negative 6 is on the left side of negative 5. So negative 6 is actually smaller than negative 5. That becomes a wrong answer. So what happens is if you multiply by a negative, you must change the original inequalities sign. And now it would work. If I plug in 6 for x, I would get that negative 6 is less than negative 5, and that now is true, and now it has the same answers. In other words, I can plug in 6 or 7 or 8, and I would still end up graphing the same idea. Okay, or all the numbers are still the same. And the reason I had to say that is because you need to remember, in order to solve an absolute value equation, you first isolate your absolute value. Well, we're still going to do that with inequalities. The second step is to write your solutions, write your two equations. And you're still going to write two equations. The difference, though, now is when you write your negative equation, you must do what? You must switch your sign. And then, as of course, you still must solve your equation at the end. So this is to solve absolute inequalities. So just remember, you must switch that sign. All right, so what we're going to do is we're going to practice some of these. So let's flip a couple pages in your text or in your packet all the way down to Talk the Talk, which is 1025. And we're going to solve this equation number A, and then you're going to finish the rest with your table. And I'm going to show you how to solve this. So the first step is always to isolate your absolute values. And if you look at this, we have absolute value of, I'll rewrite your equations so you can see a little better, x plus 3 less than 4. That's our equation. And if you notice, it's already isolated because where this inequality symbol is, there's nothing multiplying or adding, so we are completely isolated. Okay, so we are going to still follow our same rules. The second step is to rewrite your equations. My first equation is drop the absolute value and copy your equation. I always like to write both equations at once. The second one would be drop the absolute value. And this one, remember, we're going to write the opposite answer, so the negative answer. And if we write a negative answer, we now learned we must switch the sign. So if you switch the sign, then switch the sign. Third step is to solve. Well, to solve this, I'm going to subtract 3. Those go away. I get x, bring down my symbol, is 4 minus 1. X must be less than 1. Over here again, I subtract 3, that cancels. I get x, bring down my symbol, greater than negative 7. And what we're going to do now is we're going to graph this. Okay, so over here on my equation, I will graph x's bigger than negative 7. So I'm going to find on my number line negative 7. Here's negative 7. I'm going to put a circle there. If it was underlined greater than or equal to, I would color it in. This one is not, so I leave it. And I'm going to shade all of the x's that are bigger. So I'm going to start, I always just put a really small arrow because I never know what my full answer is until I graph both. But I'm going to shade all the numbers bigger, and bigger numbers go to the right on a number line. Then I'm going to go find my other x. My other x is smaller than 1, so I find 1. Notice they kind of gave you a hint already. That was the right answer. And now I'm going to shade all the x's smaller. So now I'm going to shade them this way. And typically what you're going to do is you're going to shade all of this number line to the left in blue and all of this number line in the right in red. However, when we get our total answers, we can't kind of cross these boundaries. Okay? So what really happens is the blue mark isn't going to go past the red, and the red marks won't go past the blue. So our answer is all of the numbers in between these two. Okay, so my answers could be from -7 up to 1, in between those, but nothing past those. Okay, I want you to try now with your table B, C, D, and E, and be careful when you're solving some of these. Check your solutions at the end, and then pick up your homework. If you have not, actually you already have your homework, you should already have your homework. Now the back side of that homework page you should now be able to do. You may check your solutions at any time with the sub, and good luck. Make sure all of this gets turned in by Sunday on Google Classroom, the entire worksheet. If you do not have the worksheet, you can reprint it on Google Classroom. It is the 13.1 and 2 lesson on Google Classroom, and good luck.